Space. Many have said that it is the final frontier. Amazing manufacturing achievements have been produced by companies and governments over the last century in the field of aerospace. What if students could do this as well? Our team partnered with a small satellite research lab. Using designs from the lab, we were able to produce a prototype satellite frame. To accomplish this, we used machining as our method of manufacturing. Two types of machining were implemented. First, a water jet was used to form the side panels. Then, a shopbot, a type of CNC router, was used to machine the end cap. We faced challenges, but were ultimately successful. We started the process by designing the individual parts in Inventor. We, however, had to simplify our design in order for the machine to process it correctly. The first machine parts we created were the back and side paneling of the frame, in which we used a water jet. A water jet is industrial equipment which is capable of cutting materials by using a high-pressure jet of water. This was a very straightforward process which did not yield any problems. For the end cap, we used the ShopBot CNC router to cut the necessary aluminum. However, we first made a prototype of the end cap using scrap wood available to us. We used an appropriate size of the wood and drilled screws into the bed of the ShopBot in order for it to be secured to the machine. We then imported our file to the database of the ShopBot and let it run for 3 passes. Once this was completed, we removed any excess material and were left with a finished prototype end cap. For the final product, we had to employ the use of the miter saw in order to cut a 6-inch piece of aluminum. We then drilled in holes to secure the block on the bed of the ShopBot yet again. The file was then imported into the ShopBot and the aluminum block was milled. On our first attempt, we faced challenges in the rigidity of the bits used by the ShopBot. On the first pass of the attempt, the bit snapped in two due to a ShopBot software error.
Say something, I'm giving up on you.
Our second attempt succeeded. This process took us about 35 minutes over 30 complete passes. Once this was completed, we had to remove rough edges from the milled aluminum. And this was done by using a semi-electric bandsaw to remove about 2 inches of support material on both sides. After the material was removed, we sanded the sides to smooth out the edges. A Dremel with a grinding attachment was then used to remove any more imperfections. We then milled 8 1/8 inch holes into the end cap using the drill press. The final design was then assembled. In our design, we incorporated 4 panels and an end cap. The purpose of the frame is to ensure structural integrity of the electrical components inside the satellite. We left the bottom of the frame open to facilitate the attitude determination control system. Throughout this experience, there were a few takeaways that will be useful to understand in the future. The first being our abilities to foresee situations and prevent them. This can be attributed to the broken bit that occurred on the shock bot. With better observations, we could have prevented any damage due to it milling too deep on the first pass. The final takeaway is the possibilities of machining and its abilities to make complex and structurally sound parts.
We successfully milled aluminum. We're not fucking retarded.